Hey everybody, another exam related video. We're looking at the 2.7 calculus exam here, and I really hope you find these useful because we're going to go through all of the achieved questions from that 2020 exam in this video. So we're going to start off with question number 17, and this one, a pretty typical achieve level question. You're given the function, which is up here, you're given an x value, and you've been asked to find the gradient at that particular point. So as I said, really typical. I'm going to start the same way I did in the previous video when I had this type of question. So my function of x is equal to x cubed minus 2x squared plus 5. Again, I always write these down because I find if I don't, I make really dumb, silly math errors. Because I'm looking for the gradient, I need the gradient function. So that's my cue to differentiate. So f dash x will be equal to 3x squared minus 4x. And that 5 goes away when we differentiate, so we don't need to stress about that. I'm now going to get to x equals 4. So I know that x is equal to 4 because that's what I've been asked. So f dash 4, that will be equal to 3 times 4 squared minus 4 times 4. You can bang this out, get into your calculator, or you can do the math step by step. So 4 squared is 16, times 3 is 48. So that's going to be 48. 4 times 4 over here is 16, so that's going to be minus 16. And when I do that together, I'm going to have a gradient of 32. So that's going to be a really steep positive gradient at that particular point. Okay, we are now on to question number 18, and we've got another function is given by the function hx, and we've got it over there. Find the x coordinate. So that's a little bit different to normal. Normally they ask you for the full coordinate, but here we're just looking for the x number. So x is equal to what is kind of going to be our final answer. So find the x coordinate of the point of the graph where the function has a gradient of 5. So gradient of 5. So we know, because we're dealing with hx, we know at some point h dash x will be equal to 5, and that will be involved in our maths. So let's start off as we always do. So let's write down my function. So hx is going to be equal to 0.5 x squared plus 3x minus 1. So we are looking for, or the information we have is in relation to the gradient. So it makes sense, before we can use this information, we've actually got to differentiate. So h dash x, that's going to be equal to 0.5 times 2, which is just going to be 1. So that's actually going to be nice to differentiate. That's just going to get us to x. And then plus 3, the x drops away, and so does that minus 1. So pretty nice derivative. Now what we're going to do is h dash x, we know it's going to be 5, so we're going to substitute that in over here. So 5 will be equal to x plus 3, and when I take away 3 from both sides, x will be equal to 2. And that's the answer to our question that we posed before. The x coordinate, when the gradient is 5, is going to be 2. Don't need to find out the y value in this particular case. We are now on to question number 19, and for this question here, we've been given a graph. So again, a graph, really common achieve type question, and we've been asked to sketch the gradient function. In the actual exam, kind of down below, they had a new axis for you to draw it on, but I'm just going to draw it on my initial function over here. So the first bit of information I see is we can kind of see this here is a cubic, and it's a positive one because it's starting by going upwards. So this function, if you think about it, y as a cubic, so 3x squared, if we tried to differentiate this, we're going to have 3x squared, i.e., this here is a positive parabola if we differentiated it. So we know our shape is kind of going to be U-shaped. How the U looks, we're going to need to find some other information to figure it out. So that's the first thing I wanted to note. The next thing I want to note is this graph here has 2 nice visible turning points, and we know at these turning points, so let's call them at the TPs, we know that f dash x will be equal to 0. So what we know is we know it's going to be a positive parabola, and because f dash x will be equal to 0, we know where the 2 x-intercepts are going to be. So if we follow this point down to the x-axis, so it's going to be, I don't know, kind of here-ish, it can't be exact here, And this point here, we kind of follow that back up to the x-axis as well. So going to be there-ish. We know it's going to be a positive parabola that connects those 2 points. So forgive me as my parabola won't be that good because the computer pen's not that flash at drawing. But hopefully yours would have looked a little bit like this. There we go. So we had positive parabola and it had those 2 turning points, those 2 x-intercepts when the gradient was equal to 0. Okay, we are now looking at question number 20 from the website. So we've got the speed of an object. So straight away, before I read any more, I know it's going to be kinematics related. And speed, so we've been given this velocity formula. That's up there's the units, so we can kind of disregard that. And we've been asked for the object's acceleration when t is equal to 2. So first step, let's jot down our original function. So the velocity function is equal to 3t squared minus 5t. So to find the acceleration function, and that's because that's what we've been asked, you've got to differentiate that. So the acceleration in terms of time is always equal to the integral, or sorry, not the integral, what am I doing here? It's always equal to the derivative of the velocity. So we're going to go 3 times 2 to get us to 6, so it's going to become 6t minus 5. And we've been asked when t is equal to 2. So we know that a will be equal to 2 over there. So it's going to be 6 times 2 minus 5 equals to 7. So that's 12 minus 5 gets us to 7. And don't forget your unit. So this is going to be meters per second squared. And you can do your other units, ms minus 2 as well. So hopefully that one makes sense despite my attempts to integrate initially. Okay, we are now looking at question number 21, and f dash x, difficult to see, but we've got a gradient function here, and the original function passes through the point 3, 10, and we've been asked to find the original function. So finding the original function, we know it's going to be integration related, but let's get into it. So we know that f dash x will be equal to 3x squared, just writing down my question as I always do, minus 2x minus 4. So I'm trying to find fx, and that's always going to be the integral of f dash x in terms of x. So we're going to need to integrate. So just a reminder for integration, the way I do it is I literally write down exactly the term as it is. So there's 3x squared, and then I do plus 1. And then whatever's in the power position, I'll do that as a division. So same again for the next one. So don't forget we've got an invisible 1 by the 2 there. So it's going to be 2x1, and then plus 1, and then 1 plus 1. And then we've got minus 4x, and then more importantly, we've got that plus c. And that's going to be the annoying part of this question. So simplifying all that nonsense. So we basically got 3 divided by 3. So that's going to go away. And the power is 3, so it's going to be x cubed. The next part, I've got 2 divided by 2, and the power is going to be squared, so we're going to have minus x squared. And then we've got minus 4x, and then we've got plus c. So this is when I'm now going to use the information 3, 10. So from that, I know that x must be equal to 3, and I know that y must be equal to 10. So if you think of the equation where we're at, if you put a y there, so you can kind of see where the y is and where the x is, and we're going to substitute into those spots respectively. So from this, I know that 10 is going to be equal to 3 cubed minus 3 squared minus 4 times 3 plus c. And at this step here, just from my dealings with marking with these ones a few times, high risk of a math error here. So let's slow down and do it carefully. So we've got 10 is going to be equal to 27 minus 9 minus 12 plus c. So 27 minus 9 is 18, minus the 12 is going to be 6. So that means 10 is going to be equal to 6 plus c, and I'm going to move that 6 over by doing minus 6 to both sides, so c is going to be equal to 4. So I've got my c value, and now I'm just going to state my equation. I'm going to do it over here because I've run out of room. So therefore, my 3 dots, therefore, y, oh no, I should say fx actually, because the question's asked us about fx. So fx will be equal to, and we've got x cubed, and just to note, I'm looking at this line, except I'm adding in the c, minus x squared minus 4x, and then I've got plus that 4 that I just calculated. If you can get to that, you're going to get an achieved mark. So pretty messy, long achieved mark there, I think, but it is what it is. We are now up to question 22, which is the last achieved question from this set of exams. So we've got the original function, fx, or then that's interesting, there's a k there. It has a tangent with a gradient of 15 at x equals 2. Find the value of k. So these questions, normally when it has a k, and they typically are higher in terms of kind of achievement level, so they're normally merit or excellence questions, but this must be a fairly straightforward achieved one. So let's have a look. As always, I'm going to start by writing down my function. So fx is equal to kx cubed plus 9x. So just a reminder, we're trying to figure out what this k actually is. My initial gut is, because I've been given a gradient of 15, to use that information, I need the gradient function. So I need to differentiate. So at this point here, I know that f dash x is equal to 15, and I know that x is equal to 2. So I don't have f dash x to substitute into yet, so I need to do that. So let's differentiate what I've got. So f dash x will be equal to 3kx squared plus 9. So I've now got f dash x, which I'm going to substitute in, and I also know x, so I'm going to substitute that in over there. And that will leave k as the only letter left, so I can go ahead and solve it. So that means 15 will be equal to 3k times 2 squared plus 9. So let's simplify that. That basically becomes 4 times 3 times k, so that's going to become 12k. So we've got 15 is equal to 12k plus 9. I'm going to take away 9 from both sides, so 12k is equal to 6. And then finally, I'm going to divide both sides by 12. So k is equal to 1/2 or 0.5, whichever you prefer. I'm normally a big fan of fractions, but I get some people like decimals as well. So that wraps up the last question. Hopefully you found this video really helpful for your exams. Keep an eye out for the other videos. There's going to be heaps and heaps of other calculus and algebra ones coming out soon. Best of luck for your exams.